All right, so this is similar to, I think, one of your homework problems in this homework set. We're looking at decaying population two different ways. So we're told the town has a population of 850 people at time zero, so whatever year that is. We want to write a formula for the population if it shrinks by 4% per year. So this is a constant. This is a constant percent change, right? And I like to think about how to do these in terms of like sale prices, right? Because if you went and, you're looking at buying a shirt or some shoes or whatever, and the store says, okay, it's 4% off. That's a weird percent, but whatever. What percent of the original price is it? It's going to be 100% minus the 4%, right? So it's going to be 96% of the original cost. And when we think about our AB to the T model, of course, A is our initial condition, so that's at 850 people, right? This is our A or our P0. That B is how much remains from the previous year or the previous whatever the time increment is. So we're going to look at this and say, maybe I should do P of T. P of T, our population, 850. And our B in this case, it's not 1.04 because that would be if the population was increasing. It's going to be 1 minus 0.04. So it's going to be 96%, 0.96 to the T. Now that's going to be different than if it shrinks at a continuous rate of 4% per year. That one now, we're just going to say, hey, that's a PE to the KT, right? We got 850 initial, e to the negative 0.04 t. So the continuous rate functions are a little bit easier to write than the constant percent change. But that's really all that there is to that. And I can ask you, what will be the population in some number of years, or how many years until it gets to this population. I might ask what's an appropriate domain, right? Because this model is not going to hold once the population hits 0, right? But is it ever going to get to 0? No, right? Because what does our exponential decay function look like? It looks like this, and it has a horizontal asymptote at 0. So our population is never going to get there in mathematical theory. In reality, at some point, you're going to fall below a whole person, and the town's not going to have a population anymore. All right, so all that's left is a few extra examples. I will go put those in their own, but that was the last of what I had intended to do in class.